Or, all right, we got this. The Cartesian plane, right? Named after the mathematician Descartes. Okay, it's not that important, but it's a fun fact, I guess. We're going to look into something called the Cartesian plane and scatter plots. Once again, just to go on a quick spiel, we are learning this as a subset, a very specific part of mathematics. It's not the main part of mathematics, but it's so useful in so many other areas of math that we learn it even in elementary, middle school. So let's do this. What is a Cartesian plane? It is a coordinate system, a way to pinpoint, a way to give location, right? It's a system that describes the location of a point on a grid using a horizontal axis and a vertical axis, right? And again, because we have two lines and they both can vary, hint, hint, those are variables, and because they can vary, we need to give them variable letters. And what better letter to give variables other than x? But we can't make x the same as the vertical, so we have to give the vertical another letter. Why? And that's why we say the Cartesian plane is made up of, the grid is referred to as a Cartesian plane or the XY plane. But you have to recognize, this is something you have to memorize. Horizontal comes first. So the X comes first. Vertical comes second. So the Y comes second. What do we mean by that? You'll see when we start writing some numbers down. The Cartesian plane is made up of 4 sections. So top left, bottom left, top right, top left, bottom right. Yes, it goes in that direction. Each section is called a quadrant. Oops. Quadrant. In other words, the root word for quadrant, Greek Latin root word for quadrant, quad or quarter, right? So 4. Label this just to humor me. This is considered the first quadrant, the top right. Why does that make sense? All the numbers are positive. And anytime we draw a graph, don't we always draw it like this? Like, this is my money going up per time. Like, you get what I'm saying, right? We always seem to draw as we go in the positive direction and we go up in the positive direction. But since we're in math, negative values are also true, like it exists. So you go to the left and say the y values are the same, but the x values could be a negative. So this is quadrant 2. And on the bottom right, would you write quadrant 3 and quadrant 4? Do you have to do Roman numerals? Not necessarily. However, if you started just writing 1, 2, and 3, 4, that might confuse you with the actual numbers we're using in the grid. So let's keep it as Roman numerals. Okay, the quadrants are numbered, well, there it is. 1, 2, 3, 4. Roman numerals. Did I go through the reasoning behind why Roman numerals are the way they are? Did I run that through with you when we were doing limits and stuff? Yeah. Right, how 5 is a V and 1 before 4. Yeah, right on. So we did that together. Good. I also wanted to talk a little bit about, what did I want to talk about? Horizontal and vertical, X and Y, quadrants. Oh well, I forgot what I wanted to say, but let's move on. All right, so when we're talking about location, as you can see, we need to give a location for a horizontal and a location for the vertical. we need to specify how far left or right I'm going and how far up and down I'm going. Pause right there. And this will reveal how many people have gone to like Dave and Buster's before. Left or right, up and down. Does anyone have any idea what I'm talking about? Yes. Yes. Who here has played the claw machine and you're trying to get a stuffed animal? Well, how do you play it? You press a button and then what happens to the claw? In what direction? Okay, so it goes, it starts moving towards you, okay? And then you press the button again, and then what happens? Not yet, not yet. It starts moving sideways, right? So you tell the machine how far up, down, you stop it, and you tell the machine how far left, right, you stop it, and then it will go down exactly where it is, and then you get the point. It's literally that. The only difference is you have to specify the left, right first, and then the up, down second. I can't explain this any more simply. An ordered pair is literally two numbers that are used to describe the location of a point and are always in the form of tell me the x first and tell me the y first. In other words, tell me the horizontal position first and then tell me the vertical position second. And of course, typically the easiest point to start, and so we turned it into a kind of default, 0, 0, okay? This is called the origin, the beginning. The origin is the point of intersection of the x and the y axis. It has the coordinates 0, 0. Does that make sense? How far left and right did I go if I'm living right here? I didn't go left and right. How far up and down did I go? I didn't go up and down. So this is x and y. So this is a system. Here, there's actually no calculation involved. It's just counting and using your observation skills. And so I really hope that everyone will be okay with this lesson and that they are able to identify each of these points without making careless mistakes. So let's do this as an exercise. Plot the following points on the grid above. Label each point. You ready? Point A has the coordinate 3, 5, or the ordered pair 3, 5. The point is 3, 5. The x and y is 3, 5. You get what I'm saying? I don't mean to sound like a broken record, but if a coordinate just gave you this, every mathematician worth their salt will automatically know you're talking about 3 to the right, 5 up. Does that look familiar to you? It's like Battleship, right? It's like the claw machine. Always left, right first, and then up, down second. This is A. What about B? Oh, look. Here's your first encounter with a negative value. The -2. What does that represent? The left and right. Yes. So you move 2 to the left this time, and then 4 up. Here is B. What about C? My first number is a 4. My second number is a -3. The 4 represents horizontal. The -3 represents vertical. So because it's a -3, we're going down, down, and down. That's it. Continue on, please. I'm going to pause the video and ask you to try this for the next 3 minutes. I really don't think it will take too long. Unless you're confused of what the system is. There is no math involved. You're learning to use a system. Go for it. All right, so I'm going to continue moving on because I do want to get to one use of the Cartesian coordinate plane. That's called a scatter plot. You might have done this already in science class. And it might have been annoying because depending on your background with math, you may not know why you put a whole bunch of points on a graph. Okay, so the science was the application of it. This is where you would get. This is why I like term school more than semestered, but that's just me. I'm being a teacher. You can ignore me. Here we go. A scatter plot this is what it looks like visually. You don't have to draw this, but I want you to know what it looks like so you know, like the words here make more sense to you. A scatter plot is essentially a collection of data like this. Give me two things that really, how about this? How about this? As the temperature outside goes up, the amount of money you make selling lemonade goes up. So every day you figured out how much money you make depending on the temperature outside. So sometimes when it's cold, you don't make much because people aren't thirsty. The hotter it is, you make a lot of money because people are thirsty. When you take all of these points and you plot them, guess what? There is a relationship. Anyone know science class? What do you call a relationship between X and Y in this way? It is thank you, a positive correlation. You remember that from science? Say yes. Okay. No? Well, let's keep moving. A scatter plot was what I just showed you. It's literally a scatter of plots, of points. It shows a relationship between two variables. Okay? The something variable affects the value of another variable. I'm going to call this the independent affects the value of another variable. It is usually placed in the X column of a table of values like this. Okay, so this is the independent, and it's plotted on the horizontal. In other words, on a graph, I would plot the independent here. Independent. The dependent variable is affected by the independent variable. It is usually placed in the Y column of a table, and it's plotted on the vertical axis. So here's my Y. So do you see the relationship even with the money thing? If the how about this? How about this? It might make more sense if I said, this is the amount of hours I work at a job, and this is how much money I earn. So if I earn zero, if I work 0 hours, I make 0 money. If I work 1 hour, I make, let's say, $15. If I worked 2 hours, I make $30. 3 hours, 45, so on and so forth. There is a relationship with these two. And here's the connection. It's not even math. What controls what? Does the amount of money control how much hours I work? Or does the hours I work control how much money I make? You're not going to get paid if you don't work. So the hours come first. And this is what I mean by independent versus dependent. Okay? So let's take a look at this example. Example A. A group of 10 students recorded the number of hours they studied for a test and their test scores. Identify the independent and dependent variables. Explain yourself. So, someone wants to help out the class. Think carefully. What controls what? What affects the other? What is the independent, right?
The study hours,
Right. Well, and that sort of makes sense from a logic perspective too, because you study before the test happens. You don't get the test and you get a mark and then you study for afterwards, right? Our study, the dependent variable, it will depend on how much you study, right? You can say the hour studied will affect how well you perform on a test, right? So test mark depends on our study. So you know what dependent is and you know what independent is. If this is easy for you, if this is just like easy sauce, see if you can translate data into a scatter plot. I provide for you a T-chart, a table of values, with something on the left column and something on the right column. See if you can use what we just said was independent and dependent and graph it correctly onto a graph. Please include proper arrows for your X and Y axes. By that I mean, sorry, let me erase all this except for there. Okay. Please include proper arrows for your X and Y. Please also properly label them with appropriate values for your axes, units I mean, and go ahead. So I am going to give you a quick hint. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe it makes sense to go up by tens. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe it makes sense. Oh no, maybe it makes sense to go up by half hours. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Go ahead. If you are done, I'll let you self-direct yourself for a little bit. If you have completed your scatter plot to show the relationship, go to the next page and see if you can verbally communicate a little bit about what this graph shows. I'll pause the video. Yes, pause the video once I fix this. What's up?
I was going to do mine the other way around. As in, like doing test scores on the bottom and hours on the top, on the.
Oh, I see.
On the y-axis. Can I do it that way as well?
Because of what we're trying to accomplish here, in other words, because we're trying to show what affects what, the independent variable must always be on the bottom, no matter what.
Okay.
We'll just finish this. 475, 140, and 7, 100. Okay, so from this, so this is what you would do in science too, right? Most of these seem to follow a kind of trend. Most of these hover around a same trajectory. And so you can say, oh, maybe, just maybe, if this relationship is true, any further data points that we have could sort of follow that trend as well, and this keeps on going forever in the same direction. If it's possible to do negative hours of study, right? Maybe it would follow that trend as well. And that's sort of the goal of mathematics, that we'd be able to see patterns in that way. So let's talk about this. I hope your graph looks somewhat similar to this. If not, or I'm going too fast, make sure you do it and check it through the video. Describe what each point on the graph represents. This is not math, it's just communication. What does each point represent? Yeah. Who is they? How many students? What does each dot represent? Right. So what I was actually trying to get at was each dot represents just one student, and that's why you have 10 dots, right? Just as Ariane was saying. So each point represents one student's hours studied and test score together. So one point gives you two pieces of information. It's not math anymore. If you have a point, 150, right? It's two numbers. So every single one of these points gives you two valuable pieces of information. And so here's the magic of it. A single dot gives you a lot of data. And what you do with that data, we'll see later. Okay? Each point represents one student's hour studied and the test score together. Okay? And another thing I want to add is just, it is one data, okay, or trial out of an entire sample of data or trials. In other words, one data is just one thing. It was one instance. It's one person. It's one attempt. You need lots and lots of those dots to make sense of the entire picture. So I hope you get that. So here's a bit of a science class. Describe the relationship. How would you properly describe a relationship between X and Y? I'm not going to put you guys on the spot. I have a couple of students for my science class here, but I'm not going to call them out. Anyone? What is a proper way of describing something? And be wrong. You could use your own words, right? I thought it's a positive correlation. So when you write that, let's say in a science lab report, what you might want to say is something along the lines of, right? So I'll copy that. So there is a positive correlation. What does that mean? It means as, or you could use if, as the hours studied increases, the test score increases. You give a direction for both. If one increases, the other increases. Or you can say, if one increases, the other decreases. You could say, if one decreases, this increases. Or you can say, if this decreases, that. There's four different possibilities, right? Well, of course, you can say there's no pattern as well. But anyways, last thing before I set you off on a bit of a wellness break and you guys can chill. There's one piece of data that just does not seem to work. What is it? One piece of data just doesn't seem to fit in with the rest of the crowd. Yeah. Yeah, the guy that studied 2 hours. What the heck, man? What is this? Explain. What the heck is this? How could this be possible? You only studied for 2 hours and you got 100%? That's rude. Okay? There could be a lot of explanations for that, I'm sure, but does it fit the pattern? No. And there are times when that happens. Okay? So an outlier. Here's one example. When I was in university, when I decided, you know what, being a doctor is not for me. I don't want that life because it's really depressing in the hospital. All you do is see sick people. I moved on and said, what do I do with my science career? And I'm like, well, maybe I still want to help people and I like science, maybe I'll go into research. So I went into a lab that was investigating cancer cells. One of the jobs that I had to do was to take a sample of cells on a microscope, dye it with a blue ink, let the cells absorb the ink, and check which ones had a lot more dye than others. Why? That explained that those type of cells were absorbing a lot more from the outside. It was a special kind of research project, whatever. Majority of the count had about, let's say, like 50 per slide. 50 per slide, 51, 49, 51, 52, 40, whatever. And then there was one that had 100. That was clearly double the other ones. Do I take that data and say that's correct? No, it only happened once. And so you say, oh, that is a freak accident. That was an outlier. And so you remove that data and say that shouldn't count. If it happens more than once, tough luck. You got to add it in because that is what makes scientific integrity. But if it happens just once, you're like, that doesn't fit the mold. Yes, it happened, but it could have been a freak accident. Maybe this person knew the topic really well and didn't have to study much. Maybe they cheated. I don't know, but this might have been the case. But either way, let's go all the way to the bottom. An outlier is a point that is separated from the main body of data on the graph. You can discard an outlier if you know that is not representative of your relationship. Right? But if you see more than one, then you have to raise an eyebrow and be like, why is it not a freak accident? That's science. Anyways, identify an outlier. 2, 100 is an outlier. Do you like how I wrote it as a coordinate? Any mathematician worth their salt will see that and know exactly what the 2 means and know exactly what the 100 means. You don't have to explain any more than 2, 100. Is an outlier. What might cause an outlier in this data? Subject of interest, right? Subject is interesting, right, to the student. Maybe the student cheated, right? Maybe they got lucky in guessing all the answers, right? I don't know, okay? But either way, the answers can vary. I do not know. So here is the Cartesian plane. It is very important that you become very comfortable with this system. Not even math, because we'll be doing a lot of math with this later on, but probably also in grade 9 and grade 10 and so on. So you must know this and learn how to read this like you were doing the ABCs. We're going to go on a little bit of a wellness break after, but if you are keen on staying here because you're going to chill, at least for the next 10 minutes, would you try doing this other puzzle? If you're done with puzzles, I invite you to try the homework questions on the back as well. But that last page is yours to do. Okay. I'll pause this here.